Almost every fiber laser that starts cutting badly has one of three faults, and none of them are the laser source. It is the chiller, the optics, or the nozzle. By the end of this, you will be able to tell which one you have from the cut edge alone, and the third one is the one most shops get wrong every single day. Start with heat. A fiber laser is efficient by industrial standards, but a large part of the electrical power you feed it still leaves as heat, not light. That heat has to be pulled out of the laser source, out of the fiber, and out of the cutting head. And the machine that does that is the chiller. It is not an accessory. It is life support. A chiller normally runs two separate loops at different temperatures, a cold loop for the laser source and a warmer loop for the optics and the cutting head. They are split deliberately because the source wants stable cold water while the head must be kept above the dew point of the air in the shop. That dew point rule is where people get burned. Run the head loop too cold on a humid day and moisture condenses on cold optical surfaces and connectors inside the machine. Water on a lens under kilowatts of beam does not evaporate quietly. It leaves a mark, and then the mark absorbs. A good chiller measures room humidity and shifts its set point to stay clear of that. The other chiller killer is the water itself. These circuits want clean, treated coolant, filters changed, and no scalar algae. A slowly fouling heat exchanger does not trip an alarm on day one. It just lets the source creep warmer, so the machine derates or faults out mid-program on the hottest afternoon of the year. Second failure, the optics. In a fiber machine, the beam leaves the fiber, is collimated, then focused, and the last thing before the plate is a cheap, flat protective window called the cover glass. It is there to be destroyed instead of the focusing lens, and it costs a tiny fraction of what it protects. Here is the part that catches people. Contaminated optics do not fail suddenly. Spatter and fumes settle on the glass. That dirt absorbs beam energy, the glass heats, and the heated glass bends the beam slightly. Your focus drifts down into the plate while the control still reports the number you set. The cut quality falls first, and the alarm comes much later. So the symptom to know is this. If cutting was fine this morning, and by afternoon the same program, same material, and same gas is leaving a rough lower edge and struggling to pierce, suspect the cover glass before you touch a single cutting parameter. Check it in clean light and change it rather than wiping abrasive spatter across it. Third, the nozzle, and this is the one abused daily. The nozzle does no cutting. It shapes the assist gas into a stable column around the beam so molten metal is blown down and out of the kerf. Its bore size, its condition, and its height above the plate decide whether that gas column holds together. Two things wreck it. Standoff, because the head runs within about a millimeter of the plate, and a tip-up or a collision leaves the orifice dinged. And concentricity, because the beam has to come through the center of that hole. Off-center, the gas flow is lopsided, and you get dross on one side of every part and clean edges on the other. That one-sided dross is a fingerprint, not a mystery. So run it as a routine, not a repair. Cover glass checked every shift, nozzle inspected and centered whenever the cut changes, chiller filters and coolant on a calendar, and the head loop kept above dew point. 3 consumable level items decide almost all of your cut quality and most of your downtime. Next episode, how a CNC tube laser cuts perfect joints, including 3-dimensional bevels.